So, what we're going to be discussing now are fractional exponents. Presumably you've already seen positive exponents, you've seen negative exponents, and now we're going to figure out what it means when we have fractions and exponents. So if we get x to the 4 times x to the 5, and we look at the bases. So if the bases are the same, then in this case they're both x, then that's going to be equal to x to the 4 plus 5, which is equal to x to the 9. So now, that's that for. Let's say we had root x times root x. So the square root of x times the square root of x, if we're not sure, let's quickly remind ourselves. If we have the square root of something times itself, so the root 9 times root 9 is 3 times 3, which is 9, and root 16 times root 16 is 4 times 4, which is 16, and so on and so forth. And not as obvious, the root 7 times root 7 is going to be, for example, 7, because square root means what multiplied by itself gives us 7, and now multiply it by itself, and that will give us 7. So, keeping these things in mind, root x times root x is going to be equal to x. Nothing too shocking there. Now what we're going to do is we're going to say, I want to know what exponent this is. So I'm going to say I'm going to say that x to the a, and I don't know what a is, but x to the a is going to be equal to root x. So instead of writing root x times root x equals x, I'm going to say that x to the a times x to the a equals x. So instead of root x, I just wrote it as x to the a. Now another way of doing that, we have x to the a to the x to the a. That's like saying x to the a plus a equals x, and x to the a plus a is 2a equals x. Now, I've been writing x here, but there's kind of an invisible exponent there as well. Whenever we have an x alone, really x is the same thing as x to the 1. X to the 1, x to the 1. So x to the 2a is equal to 1. And if the bottoms are the same, then the exponents also have to be the same. So that tells us that 2a has to be equal to 1, and therefore a has to be equal to a half. And so, putting that into there, what we see is that x to the a is root x, or x to the 1/2 equals root x. So x to the 1/2 means root x. Okay, let's do the same type of thing. So I'm going to say that the cube root of x, so that's something that has to be multiplied by itself 3 times. So the cube root of x multiplied by itself 3 times would be equal to x. And I'm going to do one of those substitution things again. So I'm going to say x to the, we'll use b, is the cube root of x. So I could say now that x to the b times x to the b times x to the b equals x to the, and it would be a 1, because this was a 1 as well. X to the b times x to the b times x to the b, another way of writing that is x to the b plus b plus b equals x to the 1. Or I could write this as x to the 3b equals x to the 1. The bottoms are the same, so the top has to be the same. So 3b has to be equal to 1, which means that b is going to be equal to a third. And then looking at that, we know that, so that tells us that, putting it all together, x to the 1/3 equals the cube root of x. So x to the 1 over 3 is the cube root of x. So it seems like taking these two together, right? So we saw that x to the 1/2 was the square root of x, and x to the 1/3 is the cube root of x. So presumably, if we were going to extend this a little bit further, we might say if I had x to the 1 over 7, that would be the 7th root of x, and so on and so forth. Now, all these fractions only had 1s on the top. Let's say it had something else. So let's say instead of those guys, we had the cube root, we had the cube root of x to the 7, and the cube root of x to the 7, and the cube root of x to the 7. So the cube root of something means something that if we multiply it by itself 3 times, we're going to get that number. So the cube root of x to the 7 cubed multiplied by itself 3 times is going to be x to the 7. We'll do the same trick. We'll say x to the c is the cube root of x to the 7. So we're going to get x to the c times x to the c times x to the c equals x to the 7. Maybe I should do 7. So we're going to get x to the c plus c plus c equals x to the 7. So x to the 3c equals 7. So we know that, x to the 7. So we know that if the bases are the same, the exponents have to be the same. 3c equals 7, c equals 7/3. Or, to write it in another way, what we know is that x to the 7 over 3 equals the cube root of x to the 7. And if we look at it, the denominator is the root, and the exponent kind of stays as an exponent.